technology. Today we are going to discuss about communication system in modulation. First one is introduction to communication system. That is, what is communication system? A communication system is an organized framework designed to transmit information from a source to destination with minimum loss and distortion. The information may exist in the depending on the application. In engineering terms, a communication system ensures that the transmitted message reaches the receiver accurately and efficiently. The presence of noise and channels impairment. Modulation is one of the most critical techniques used in achieve reliable communication over long distance. Objectives of a communication system. That is, the primary objective of a communication system is to transmit information accurately from the sender to the receiver. This involves minimizing error caused by noise, interference and signal attenuation. Another important objective is efficient utilization of bandwidth and power. Modulation techniques are designed to achieve these objectives while maintaining system simplicity and cost effectiveness. Key energy objectives: reliability, efficiency, speed, quality and security. Basic block diagram of the communication system. That is transmitter and channel and receiver session. That is transmitter. Transmitter is a typical communication system consists of a information source, transmitter, channel and receiver and destination. Each block has a specific function in signal processing and transmission. The transmitter converts the message into suitable form of transmission, while receiver extracts the original information from the received signal. Information source. The information source generates the message signal that needs to be transmitted. This signal can be analog such as speech or digital such as binary data. The characteristics of source determine the type of modulation and communication technique is used. Key aspect of information sources. The component that produces the message or data for transmission such as person, computer or sensor. Types of information: analog and digital. That is, analog signal is example is speech, music or video signal. Digital, computer files, text or data. Examples are the microphones, cameras, keyboards and sensors. Function: it creates the initial message signal, that is non-electrical or electrical, that is subsequently produced by the transmitter. Transmitter. The transmitter processes the message signal and prepares it for transmission through the channel. It includes modulation, amplification and filtering stages. Key function: signal conversion, modulation, amplification and transmission. Signal conversion takes non-electrical signal, that is sounds and video, converts them to electrical signal or process digital data into transmitter form. Modulation adds the information message signal onto a higher frequency carrier signal by varying its amplitude or frequency. Analog signal. Analog signals are continuous time varying electromagnetic waves that represent data by continuously changing their amplitude, frequency or phase. They are used in communication system, that is AM, FM radio, TV, to transmit information directly without digital conversion. Key advantages include simpler, low cost hardware and low bandwidth requirements, but they are highly susceptible to noise and distortion. Digital signal. Digital signal and communication system involves transmitting information using discrete binary signals. Discrete binary signals mean, that is zeros and ones, to ensure high reliability, high noise immunity and efficient data processing. They consist of a transmitter, that is coding, modulation, channel and receiver. Receiver is demodulation, decoding process, replacing analog system with superior performance, bandwidth management, security and error correction for applications like 4G, internet and satellite communication. Introduction to modulation. Modulation is the process of encoding low frequency information like voice or data onto a high frequency carrier wave by the carrier amplitude, frequency or phase, making the signal suitable for long distance transmission. This allows multiple signals to share the airways efficiency, enables smaller antennas and improves signal quality, with demodulation being the reverse process at the receiver to extract the original message. This is one of the amplitude modulation signals frequency. Classification of modulation. Modulation is classified into two types, that is analog modulation and digital modulation. Analog modulation is classified into amplitude, frequency, phase and pulse modulation. Amplitude modulation, that is amplitude modulation changes the amplitude of the carrier wave. Frequency modulation is changes the frequency of the carrier wave. Phase modulation changes the phase of the carrier wave. Digital modulation used to transmit only binary data, that is ones and zeros. Digital modulation is amplitude shift keying, frequency shift keying and phase shift keying and quadrature amplitude modulation. Then pulse modulation. Pulse modulation is used to analog signal but with a pulse train as a carrier. Pulse modulation is classified into pulse amplitude modulation, pulse width modulation, pulse position modulation and pulse code modulation. Types of amplitude modulation. The major type of AM, that is DSFC, DSB-FC, DSS, DSB-SC. Single sideband suppressed carrier, vestigial sideband, then single sideband reduced carrier. Modulation index derivation, that is mathematical derivation of the modulation index. Modulation index mu is equal to AM divided by AC. AM, consider maximum and minimum amplitude of the wave as A max and A minimum. A max is equal to AC plus AM. A min is equal to AC minus AM. FM characteristic, constant amplitude, frequency deviation, high noise impunity, wide bandwidth, modulation index. Digital modulation overview. Core concept and techniques digital modulation act as a bridge between digital baseband signals and physical transmission media by altering a high frequency carrier wave. Amplitude shift keying, frequency shift keying, phase shift keying, quadrature amplitude modulation. Amplitude shift keying modulates amplitude often used in a fiber opticals. Frequency shift keying varies frequency between predefined values. Phase shift keying adjusts the carrier pace and including binary PSK and QPSK. Quadrature amplitude modulation combines both amplitude and phase variation for high speed, high bandwidth efficiency. Differential phase shift keying. For the perfect detection of a phase modulated signal, the receiver needs a reference signal. But if differential encoding and phase shift keying are made together at the transmitter, the technique is called as differential phase shift keying. For the transmission of a symbol 1, the phase is unchanged, whereas for transmission of a symbol 0, the phase of a signal is changed by 180. That is digital signal, that is analog signal. Power efficiency. Power efficiency is a measure of how much signal power should be increased to achieve particular bit error rate for a given modulation scheme. Ability of modulation technique to perceive the fidelity of the digital message at the lower. Designer can increase noise immunity by increasing signal power. Bandwidth efficiency. Ability to according data within intimated bandwidth. Trade-off between data rate and pulse width. Easy to implement and cost effective. Practical constraint of modulation. Hardware limitation affect modulation charge. Power and bandwidth constraints must be considered. System design balances performance and cost. Modulation in embedded system. Embedded system use simple digital modulation. Low power consumption is essential. Used in IoT and sensor networks. Performance matrices in modulation. Key matrices include Berg, SNR and bandwidth. Performance evaluation aims with reliability. Engineer selects modulation based on matrices. Advantages of digital modulation: high noise immunity and flexibility. Supports high speed data transmission. Preferred in modern communication system. Communication system. Communication system architecture defines how information flows from source to destination through the multiple function block. It includes source encoding, modulation, transmission, channel and demodulation, and destination decoding. Proper architecture design ensures reliability, efficiency, scalability of a communication system. This is the block diagram of communication system architecture. Channel characteristics and limitation. Communication channels introduce noise, attenuation and distortion. Channel properties vary based on medium such as air, cable or fiber. Understanding channel behavior is essential for modulation section. Receiver processing stage. The receiver captures the transmitted signal from the signal. It amplifies, demodulates and filters the signal. Final output is reconstructed information close to the signal. Signal attenuation in communication. Attenuation refers to reduction in signal strength during transmission. It increases with distance and frequency. Modulation helps reduce the attenuation effects in long distance communication. Distortion in modulating signal. Distortion alters the shape of the transmitted signal. It occurs due to non-linear components and channel imperfections. Proper modulation and filtering minimize distortion. Importance of frequency allocation. Frequency allocation prevents interference between communication system. Regularity board is assigned frequency bands for different services. Modulation allows efficient use of allocated frequencies. Single channel versus multi-channel communication. That is, single channel system transmit only one signal at a time. Multi-channel system support multiple signals simultaneously. Modulation enables multi-channel transmission using different carriers. Analog signal transmission uses. Analog signals are continuously varying and noise sensitive. Noise directly affects signal amplitude. Modulation techniques attempt to improve analog signal robustness. Digital signal transmission benefits. Analog signals are continuously varying and noise sensitive. Noise directly affects signal amplitude. Modulation techniques attempt to improve analog to signal robustness. That is, analog signal transmission benefit. Digital signal transmission benefits. Source coding importance. Source coding reduces redundancy in data. It improves bandwidth efficiency. Examples include compression techniques. Channel coding concept. Channel coding adds redundancy for error reduction. It improves reliability over noisy channels. Widely used in digital communication system. Line coding techniques. Line coding converts binary data into digital signal. It ensures synchronization and error reduction used in wired communication system. Modulation versus coding. Modulation changes carrier properties. Coding improves error performance. Both work together for efficient communication. Spread spectrum techniques. Spread spectrum techniques signal over wide bandwidth. It provides security and interferences resistance. Used in wireless and military communication. Direct sequence spread spectrum. DSS spreads data using pseudo-random process. That is, it improves noise immunity. Used in CDMA system. Frequency hopping spread spectrum. FHS rapidly changes carrier frequency. It reduces interference and interception. Used in Bluetooth system. Modulation in radar system. Radar system use modulation for detection. It helps measure distance and velocity. Reliable modulation ensures accurate radar operation. Modulation in navigation systems. Navigation system relay is precision modulation. GPS used advanced digital modulation. Accurate modulation ensures position accuracy. Environmental effects on modulation. Weather affects wireless signal propagation. Rain and fog cases attenuation. Robust modulation minimizes environmental impact. Advantages of OFDM. OFDM provides high resistance to multipath fading. It supports high data rates, efficient utilization of available bandwidth. Orthogonal frequency division multiplexing. That is, orthogonal frequency division multiplexing divides data into multiple low rate subcarriers. Each subcarrier is orthogonal to others, reducing the interference. OFDM is widely used in Wi-Fi, LTE and 5G system. Disadvantages of OFDM. OFDM have high peak to average power ratio. Transmitter design becomes complex, requires accurate synchronization. Multiple access techniques overview. Multiple access techniques allows multiple users to share a communication channel. Efficient sharing improves system capacity. Modulation works along with multiple access scheme. Frequency division multiple access. FDMA assigns different frequency bands to user. User transmits simultaneously without interference. it is used in earlier cellular system. Time division multiple access, that is TDMA. TDMA divides channel into slots. Each user transmits in assigned time slots. Improves channel utilization. Code division multiple access, that is CDMA. CDMA uses unique codes for each other. Signals share same frequency band. Provides high security and interference resistance. Comparison of multiple access techniques. FDMA uses frequency separation. TDMA uses time separation. CDMA uses code separation. Role of modulation in multiple access, that is modulation enables separates of users. It reduces mutual interference, ensures reliable multi-user communication. Modulation in 4G communication systems. 4G systems use OFDM and QAM. High data rates are achieved. Supports multimedia services. Modulation in 5G communication systems. 5G uses advanced modulation and coding schemes. Supports ultra-high data rates. Enables low latency communication. Massive MIMO and modulation. Massive MIMO uses multiple antennas. It is improves spectral efficiency. Works with the advanced modulation techniques. Modulation on Internet of Things, that is IoT. IoT devices requires low power modulation. Simple modulation techniques are preferred. Ensures long battery life. Low power wide area networks. LP band. LP band supports long range communication. Uses low data rate modulation. Ideal for IoT applications. Software defined radio, that is SDR. SDR implements modulation in software. Offers flexibility and reconfigurability. Widely used in research and development. Hybrid modulation techniques. Combines multiple modulation methods. Improves performance. Used in advanced systems. Quality of service. Quality QoS, that is QoS ensures performance goodness. Modulation affects latency and throughput. Critical for real-time applications. Future research direction in modulation, that is research focus on higher efficiency. Supports future communication needs. Includes AI-based communication. Then the amplitude modulation. Amplitude modulation is a technique used in electronic communication system transmit like audio. This one is amplitude modulation signal. That is the carrier signal. That is carrier signal. Amplitude modulation, that is message signal and carrier signal is converted into the amplitude of the modulating signal. That is lower sideband and upper sideband signals. That is major types of AM signal. DSBFC, that is transmits the carrier along with both upper and lower sides, offering simple receivers but less power bandwidth efficient. Double sideband suppressed carrier, that is DSBSC, suppresses the carriers sending only the sidebands, saving power and doubling bandwidth efficiency compared to DSBFC used in amateur radio. Single sideband suppressed carrier, that is transmitter only one side, the signal only one side only, transmitter transmits only one side, either upper or lower, only either or upper or lower, with the carrier suppressed, maximizing power and bandwidth efficiency, ideal for long distance communication. Then vestigial sideband AM, that is transmit one full sideband, that is only one side full suppressed, transmit one full sideband and vestigial of the other, balancing bandwidth, saving with the demodulation complexity commonly used for analog television. Single sideband reduced carrier, similar to SSB-SC, but with a small part of the carrier signal is present, aiding demodulation. Advantages of the AM. Simple and cheap hardware. that is long distance communication, narrow bandwidth, easy demodulation. Simple and cheap hardware, that is AM transmitter and receiver are simpler, use fewer components like diodes for detection, and are therefore more such cheaper to build and buy. Long distance communication, AM signals can reflect off the ionosphere, allowing them to travel vast distance and cover wide areas, making them ideal for broad radio broadcasting. Narrow bandwidth, AM requires less bandwidth compared to frequency modulation. That is, frequency modulation meaning more stations can fit into a given frequency range. Easy demodulation, the process of extracting the original signal. Demodulation is straightforward, requiring minimal security. Disadvantages of AM: high susceptibility to noise. Both the desired signal and unwanted noise affect the carrier wave's amplitude, making it difficult for receiver to distinguish between them, leading to static and poor sound. Low power efficiency, a large amount of power is wasted in the carrier wave, which carries no information with only the sidebands containing the message signal. Poor audio quality, limited bandwidth around 10 kHz restricts the transmission of higher frequencies, resulting in lower fidelity for music and complex audio compared to FM. Inefficient bandwidth use, AM transmitter, the carrier and both sidebands, but only one sideband is needed inefficiently using the frequency spectrum. Frequency modulation. Frequency modulation is a signaling technique that encodes information by varying the frequency of a carrier wave in proportion to the amplitude of a modulating signal while keeping the carrier amplitude is constant. Frequency modulation is a carrier amplitude is constant. Widely used in radio broadcasting 88 to 108 MHz and telecommunications. FM offers superior noise rejection and high fidelity sound compared to the amplitude modulation. Frequency modulation is compared to amplitude modulation is super noise rejection and high fidelity sounds. In frequency modulation, the frequency of the carrier is varied according to the message signal. The amplitude of the carrier remains constant throughout modulation. FM provides better noise immunity compared to AM. This is the frequency modulation wave. That is, first one is modulating wave, second one is carrier waveform, the third wave is modulating, that is frequency modulated signal wave. FM characteristic, constant amplitude, frequency deviation, high noise immunity, wide bandwidth, modulation index. The amplitude of the FM signal is constant, allowing for better noise reduction using amplitude limiters. Frequency deviation, the instantaneous frequency of the carrier changes based on the modulating signal's amplitude. High noise immunity, due to its immunity to amplitude variation. FM is less prone to noise and interference, providing a high signal to noise ratio. Wide bandwidth, FM requires a much higher bandwidth compared to amplitude modulation AM, often employing 200 kHz channels for broadcasting. Modulation index often greater than 1, where the modulation index MF is equal to del FM equal to the fraction with numerator delta and denominator F sub m, and n fraction Fm is equal to del Fm is the ratio of frequency deviation to maximum modulating frequency. Advantages of FM: high noise impurity, superior sound quality, power efficiency, reduced interference. High noise immunity, since noise typically affects the amplitude of the signal, FM is constant. Amplitude allows for easy removal of noise via limiters, resulting in high signal to noise ratios. Superior sound quality, FM provides better audio. FM provides always better audio, making it ideal for music broadcasting. Power efficiency, FM transmitter requires less power, but sound quality is best. FM transmitter requires less power compared to AM because the transmitter does not need to handle high power linear amplification. Reduced interference, adjacent stations are separated by broad bands, minimizing the interference. Disadvantages of the FM: That is disadvantages: limited range, higher bandwidth, complex equipment, signal distortion. Limited range. FM signals are restricted to the line of sight, meaning they cannot cover large geographical areas like AM, making it unsuitable for long distance broadcasting. Higher bandwidth requirement, that is FM signal requires a wider channel bandwidth, that is often 200 kHz compared to AM. Complex equipment, the transmitter and receivers needed for FM are more complicated and expensive to design. Signal distortion, the complex modulation and demodulation process can introduce distortion if not properly managed. Phase modulation. Phase modulation is an angle modulation technique that encodes information by varying the instantaneous phase of a carrier signal in a direct proportion to an input message signal, keeping its amplitude and frequency is constant. Phase modulation has amplitude and frequency is constant. It is widely used in digital communication systems such as Wi-Fi, satellite, TV and GSM. Due to this high noise immunity and efficient signal integrity is crowded spectrums. Types of phase modulation, that is analog PM and digital PM. Analog PM, the phase changes continuously based on the analog message signal. Digital PM, that is phase shift keying of PSK. The phase changes observably based on digital data, that is amplitude and time. This is the signal of phase modulation signal. This signal is message signal. The signal is transmitted as the message signal and the output PM of the signal is this one. Digital modulation overview. Core concept and technique is digital modulation act as a bridge between digital based signals and physical transmission media, altering a high frequency carrier wave. That is ASK, FSK, PSK, QAM. Then types of digital modulation. Main types of digital modulation is ASK, FSK, PSK, QAM. Amplitude shift keying. Amplitude shift keying ASK is modulation techniques, that is A, AM and carrier frequency. Message signal, carrier signal and carrier frequency are adjusted. A, AM and carrier frequency FC are adjusted with ASK being linear modulation type. Signal representation. Binary is 1 is typically represented by a high amplitude carrier signal, while binary 0 is represented by a low or no amplitude. That is 0 stage is a lower value or no amplitude. That is signal presentation. Binary 1 value is represented as high amplitude and the carrier signal. Modulator and demodulator. That is ASK modulator often uses product modulator, which is composed of a carrier generator and a switcher for a binary signal. FSK, PSK and differential phase shift keying. Differential phase shift keying. For the perfect direction of a phase modulating signal, the receiver needs a reference signal, but if differential encoding and phase shift keying are made together at the transmitter, the technique is called differential phase shift keying. For the transmitter of a symbol 1, the phase is unchanged, whereas for transmitter of symbol 0, the phase signal is changed by 180. Merits of digital signal. Power efficiency. Power efficiency is a measure of how much signal power should be increased to achieve particular bit error rate. That is BES. Bit error rate is BES for a given modulation scheme. Ability of a modulation technique is to preserve the fidelity of the digital message at the lower power. Designer can increase noise immunity by increasing signal power. Bandwidth efficiency. Ability to according to data within a limited bandwidth. Trade-off between data and pulse with easy to implement and cost effective to operate. Importance of frequency allocation. Frequency allocation prevents interference between communication systems. Regularity bodies assign frequency bands for different services. Modulation allows efficient use of allocated frequencies. Single channel that versus multiple channel system. Source Channel coding adds redundancy for error reduction. It improves reliability over noisy channels. Widely used in digital communication system. Software defined radios SDR. SDR implements modulation in software, offer flexibility and reconfigurability, widely used in research and development. Hybrid modulation techniques, that is combines multiple modulation methods, improves performance, used in advanced system. Overall conclusion of communication system modulation. Key conclusion of communication system modulation, that is enables long distance transmission. Low frequency baseband signals like voice cannot travel far and require impossibly large antennas. Modulation translates this to higher frequencies, which requires much smaller practical antenna size, typically and propagate better. Typically lambda by 4L and propagate better. Enable frequency division multiplexing (FDM). That is, modulation allows multiple signals to share the same medium, example airwaves, cables, without interference by assigning each to a unique separate high frequency band. Improves signal quality, that is noise immunity. While analog modulation is susceptible to noise, frequency modulation and phase modulation offer significantly better immunity to noise and interference, providing clearer, high fidelity communication. Enables digital communication efficiency, that is digital modulation techniques ASK, FSK, PSK, QAM transforms data into pulses, allowing for easier, more robust signal regeneration at the receiver and error correction. High order modulation like 256 QAM increases spectral efficiency, packing more data into the same bandwidth. Context dependent selection. The choice of modulation techniques involves a trade-off between bandwidth efficiency, power efficiency and hardware complexity. For instance, while high order QAM is efficient for high-speed data, it requires a higher signal-to-noise ratio and is more susceptible to noise than lower order schemes. Evaluation to advanced techniques. As a communication needs as involves, technologies like orthogonal frequency division multiplexing (OFDM) are used in 4G and 5G to handle interferences, providing superior robustness to multipath fading and higher data through output. Enables communication systems in modulation is enables long distance transmission, enables frequency division multiplexing, improves signal quality and noise immunity, enables digital communication efficiency, context dependent selection, evaluation to advanced techniques. Frequency hopping spread spectrum and modulation in radar system, source encoding importance, line coding techniques, modulation versus coding. Then analog to signal transmission and digital to signal transmission. This one is all of importance of frequency allocation. Thank you.